Winter had turned the German repair depot into a landscape of grease-stained concrete and ghost breath. The compound sat outside Cologne, half buried in pines, screened from Allied bombers by camouflage netting so worn it barely held together. The sky that morning was the color of exhaustion, pale, endless, crushing. Hauptsturmführer Klaus Weber stood in the cavernous workshop, stamping his feet against cold that had long since stopped bothering him, watching as a flatbed truck reversed slowly into the hangar. On the truck bed sat a Sherman tank, captured intact somewhere in the Ardennes push that had failed. It was mud-brown, angular, unremarkable at first glance. The American invasion had been grinding across Europe for nearly a year, and tens of thousands of these machines had bled across French soil, left their tracks in the bocage, broken through hedgerows into German farmland. To the men standing in that workshop, the Sherman represented something they could finally dissect, finally understand. That understanding would haunt them for decades. Klaus was not a soldier by preference. He was a mechanical engineer who had been conscripted in 1943, reassigned to depot work because he'd worked in locomotive manufacture before the war. He had the bearing of a man who had seen enough death in the factories, in the air raids, in the replacement depot where wounded vehicles arrived as twisted skeletons, to develop a kind of philosophical distance from it. His assistant Friedrich was younger, maybe 25, with the nervous energy of someone who'd grown up in the Hitler Youth and still half believed in miraculous weapons that would turn the tide. Beside them stood Major Gottlieb, an ordnance officer who'd made the decision to bring the Sherman here for detailed examination. Gottlieb wore the slight slouch of a man aware that the war was ending, and not in Germany's favor, but still clinging to procedure, to protocol, to the belief that understanding might yet yield some advantage. The tank was hauled off the truck with chains and pulleys, positioned on the workshop floor under brutal electric lights that cast everything in shades of white and shadow. The first thing that struck Klaus was how accessible everything was. The side panels came off with a handful of bolts. No welds sealed away the interior from view. American production philosophy apparently assumed that mechanics would need to get inside regularly, that fighting vehicles broke down, that armies moved and repaired constantly. Klaus ran his hand over the interior panels as workers cleared debris from the tank's operational spaces. Dust, grease, bits of fiber and wire. The texture of a machine that had been used hard, that had endured mud and heat and the shock of shells. Friedrich opened a small water-damaged notebook he'd found in the tank's commander's locker. American English, phonetic slang, drawings of girls from magazines pinned to the turret interior, the intimate graffiti of men who'd shared a coffin-sized space and formed the kind of bond that only sustained danger could create. This one says, "Mother sends cigarettes," Friedrich translated quietly. Klaus didn't respond. The human layer beneath all the steel made him uncomfortable. It collapsed the psychological distance necessary for this work. By midday, they'd begun systematic disassembly. The transmission came free with surprising ease. The engine block was lifted out and positioned on a wooden cradle. Friedrich photographed everything with a Leica camera before and after removal. Protocol, though Klaus doubted these images would survive the war. They needed to understand the Sherman's logic, how Americans built for scale rather than for perfection. The first afternoon, they removed the turret traverse mechanism. It was simple, a hydraulic system with remarkably few moving parts. A German equivalent would have been more robust, with manual backup systems and redundancies, but this one was elegant in its minimalism. It would move fast, cycle the gun, and if it failed completely. There was no halfway. "Look at this," Klaus said to Gottlieb, pointing at the ammunition storage area. The shells were stored in boxes lined with a waxy material. Friedrich opened one and smelled it. Water. "The shells are stored in water?" he asked, incredulous. Klaus nodded slowly. "Wet stowage. They're told the glycol mixture reduces the chance of detonation if the tank is hit, creates an ablative effect if the armor is penetrated." Gottlieb leaned close, considering the implication. American ingenuity meant accepting that ammunition could cook off, so they designed systems to suppress that possibility. The philosophy was not perfection but probability reduction. It meant accepting casualties, building systems that acknowledged failure as inevitable and designed around it. The radio installation took an entire day to document. The Sherman had radios, not just the tank commander's set, but systems that spoke to other units, to higher command, to air support. A German panzer crew of the same period might have a single shortwave set, often unreliable, often jammed. The American system was redundant, integrated, assumed communication as essential to tactics. Klaus found diagrams laminated in plastic, maintenance logs written on cardboard that would survive mud and weather. Everything spoke to a civilization that had decided to win through logistics and coordination rather than through individual tank quality. The driving compartment, Friedrich said on the third day, settling into the driver's position. I can actually reach everything. The pedals are reasonable. The steering is hydraulic assisted. In German tanks, driving was the exhausting affair. Mechanical steering that required shoulder strength, gear shifts that demanded precise understanding of the engine's temperament. They built this for a teenager, Friedrich said, and Klaus heard something like resentment in the younger man's voice. Friedrich had grown up in a military culture that valorized hardship, that saw comfort as weakness. The American approach, let the machine absorb the difficulty, let the man operate efficiently, was philosophically alien. The transmission they removed and disassembled on a workbench under magnifying lamps revealed production standards that made Klaus catch his breath. Every tolerances was generous by German standards, maybe by 2 or 3 hundredths of a millimeter more forgiving than equivalent German components. Standardization was total, parts stamped with manufacturer codes that could be traced to one of dozens of American factories. Gottlieb examined the documents that came with the tank, parts lists that referenced not individual vehicles, but families of compatible components. In theory, Gottlieb said slowly, you could take components from 24 different Shermans and assemble a functioning transmission. In theory, Klaus agreed, we could never do that. Klaus said nothing because the statement was obviously true. Every German engine was hand-fitted to its tank. German standardization was aspirational. American standardization was law. German factories competed with each other, maintained pride in proprietary designs. American factories answered to quotas and contracts written in bureaucratic precision. One built craft, the other built capacity. By the second week, word had filtered through the depot about the examination happening in the main hangar. Officers came through, looked at the dissected tank, made comments about American material wealth and engineering simplicity. None of them seemed to understand what Klaus was beginning to understand, that this wasn't about the tank itself. It was about what the tank represented, the mathematical inevitability of American victory. That understanding crystallized when Gottlieb brought him a set of photographs from an American tank factory. They'd arrived through intelligence channels, grainy, black and white, but clear enough. Assembly lines that stretched the length of city blocks. Hundreds of workers per station. Conveyor systems that moved tanks in various stages of completion through the factory like fish in a mechanical stream. Production rates listed in quarterly reports: 30,000 tanks in 1943, 31,000 in 1944. Germany was producing perhaps 300 tanks per month across all types. America was producing 2,500 Shermans monthly, and that was one factory among dozens. The photos showed tanks stacked in depot yards like cordwood, waiting for transport to ports, for shipment across the Atlantic, for distribution to units that would fight in Europe. Klaus stood in the photograph room, looking at these images, and felt something shift in his chest. It wasn't despair exactly, though despair would come later. It was a kind of intellectual clarity that preceded emotional reaction. He thought of the German tank factories he'd visited before the war, proud places, filled with workers who understood that they were making superior machines. He thought of the hours that went into fitting German tanks, the precision work, the individual attention to manufacturing. It was no longer a matter of which tank was technically superior. The Sherman was adequate. It could fight, move, shoot, be repaired by any mechanic with basic training and a manual written in English. And if one was destroyed, there would be another to replace it within days, because the American production system moved at a speed that made replacement automatic. "They're not trying to make the best tank," Klaus said aloud. Gottlieb looked at him. "They're trying to make enough tanks that quality becomes irrelevant. They're trying to make the problem of individual tank superiority mathematically unnecessary." It was the moment when Klaus's understanding crossed from technical to strategic, when he grasped that he was looking not at engineering, but at economics, at production capacity, at the industrial mobilization of an entire continent. Across the Atlantic, in factories that Klaus could barely imagine except through these photographs, different minds were working on the same problem from a different angle. At the Chrysler tank arsenal in Detroit, engineers and production managers were asking how many Shermans they could manufacture per week. Not how good could a single Sherman be, but how fast could they push men and machinery to produce volume. The answer was faster than anyone in Germany had imagined possible. Chrysler had built engines for automobiles, and American automobiles represented the most industrialized automotive sector in the world. Tank production was an application of automobile production technology, scaled up, simplified, made redundant in the right ways. Standardization was not a goal in American manufacturing, it was a prerequisite. Friedrich began taking measurements of every component, recording dimensions, making sketches of assembly procedures that he could infer from the physical evidence. The transmission gears meshed with tolerances that would allow random components to work together because the manufacturing process had achieved consistency. German gear manufacturing was an art. American gear manufacturing had been reduced to a science and then to a recipe. Quality control meant statistical sampling rather than individual inspection. It meant accepting a certain percentage of failure because the total production was so great that even defective components could be produced and acceptable within military specifications. Nothing about this was elegant from an engineering perspective, but from a production perspective it was genius. "The engine," Klaus said one morning, having spent hours comparing the Sherman engine to documentation on German inline power plants, "is not particularly efficient. It's not optimized for tank work. It's essentially an automotive engine with higher compression and reinforced mounts." He paused. "Because it is an automotive engine. They're using industrial engines they were already producing, already understood how to manufacture at scale." "That seems wasteful," Friedrich said. "It is. From a purity standpoint, it's terribly wasteful. But from a production standpoint, it's brilliant. You don't have to design a new engine. You don't have to train workers in new processes. You take an engine they've been producing for years and adapt it. The investment in retooling is minimal compared to the output gain." Klaus began to understand the deeper philosophy that animated American tank design. Every component was asking the same question: can this be produced in volume by workers with minimal training using existing industrial capacity? Thick armor was shaped not for ballistic efficiency, but for manufacturing convenience. The gun mounting was straightforward because complicated solutions would require specialized workers and slow production. The suspension was sturdy but not sophisticated because sophisticated meant difficult to repair in the field. Everything pointed to a civilization that had decided that winning required not masterpieces, but adequate weapons in overwhelming numbers. By the third week, the examination had begun to feel less like scientific inquiry and more like archaeology. They were excavating the logic of an entire industrial civilization through the dissected shell of its military vehicle. The documentation that came with the tank was remarkable. Maintenance manuals written for soldiers with high school educations, parts lists organized in logical sequences, troubleshooting guides that began with the most common failures and worked backward to less likely causes. German documentation assumed skilled mechanics and extensive training. American documentation assumed teenagers and sergeants, assumed that anyone should be able to maintain the vehicle with available materials and simple tools. Ammunition logistics revealed another layer of American genius. Sherman shells came standardized in dimensions, packings, and distribution. A damaged tank could be replaced with a functional one and integrated into a unit within hours because ammunition was interchangeable, because supply lines moved ammunition in standardized boxes that nested into standardized trucks driven by standardized logistics networks. German ammunition logistics were precise but fragile, specialized ammunition for specialized guns, transported in specialized containers, requiring detailed coordination to maintain. An American supply system could lose units, have convoys rerouted, face disruptions, and still maintain ammunition levels because redundancy was built in. A German supply system faced with similar disruptions would fragment. Klaus received a visitor one afternoon. General Oberst Ernst von Kessler, who commanded armor production for the Western Front, appeared in the workshop with 2 aides and an expression that suggested he already knew what conclusion awaited him. Von Kessler was a man of the old army, trained in the Weimar period, skeptical of Nazi production rhetoric, informed by actual manufacturing experience. He looked at the Sherman in its dissected state for perhaps 10 minutes, then walked slowly around the perimeter, examining the documentation that Klaus and Friedrich had arranged on tables. "How many can they produce per month?" von Kessler asked Klaus directly. "Based on the latest intelligence, between 5 and 7,000 across all Sherman variants. And we produce how many Panzers? Roughly 300 per month across all types. With component shortages, it may fall to 250 by spring." Von Kessler nodded, as though this confirmed something he'd known for some time. "The war is already over," he said quietly. "We lost it. We lost it at the moment when the American productive capacity exceeded ours by a factor of 20 and showed no signs of stopping." He paused. "We could have won if we'd destroyed them in 1942. We could have won if they'd never entered the war. But they did enter, and their factories are running at capacity. We cannot win a mathematics problem by superior geometry." It was the first time Klaus heard a senior officer acknowledge the fundamental problem. Not a tactical problem or a strategic problem, but a problem of production capacity. German officers had been trained to think in terms of maneuver, of concentration of force at the decisive point, of superior training and superior weapons, offsetting numerical advantage. Against the Americans and Soviets, those doctrines had failed because the numerical advantage was not merely numerical, but qualitative. It was sustained over time, it was reproducible, it was protected by oceans and distance and industrial capacity that multiplied faster than the German military could divide. The men who designed this tank understood something we failed to understand, von Kessler continued, looking at the Sherman's open belly. They understood that war in the 20th century is won by the side that can field the most adequate weapons in overwhelming numbers, not by the side with the most brilliant weapons. We tried to field brilliant weapons with insufficient numbers. They fielded adequate weapons in brilliant numbers. The second month of examination became more structured. Klaus and Friedrich, now authorized by von Kessler to produce a formal analysis, began compiling technical data alongside manufacturing implications. They documented production tolerances, assembly procedures, estimated labor hours per component, the sophistication level required at each stage. The picture that emerged was devastating in its clarity. A Sherman could be produced by workers with perhaps 3 weeks of training on a specific task. German tanks, because of their complexity and the necessity of hand-fitting components, required skilled machinists and assemblers with years of experience. "This is the real victory," Klaus said to Gottlieb one evening, sitting in the workshop as night fell outside. The Sherman sat between them, now partially reassembled as they tested and verified systems. Not this tank specifically, but the democratization of tank production. They've engineered tank warfare to be producible by industrial democracies rather than by militarized craft traditions. They've asked not how good can we make a tank, but how many tanks can we make with the human capital available in our country? And the answer to that question is so many that individual quality becomes irrelevant. Gottlieb was smoking a cigarette, a luxury he rarely allowed himself. "Will we include that assessment in the final report?" "We have to," Klaus said. "Any other conclusion would be a lie. We're supposed to analyze what we've learned. What we've learned is that they're going to produce more tanks, repair them faster, distribute them more efficiently, and replace losses at a rate we cannot match. We've learned that the war is no longer a war of tactics, but a war of capacity." During this same period, intelligence reports filtered through about the American supply system that had driven the breakout in France and the race across the European plain. The Red Ball Express, convoy networks designed specifically to move fuel and ammunition to forward units at a pace that kept the advance moving. Depot systems that could repair a damaged tank and return it to combat within days. Field workshops that traveled with units, capable of executing repairs that might take a German depot weeks. Spare parts depots organized with such standardization that a replacement part could be located, requisitioned, and transported within hours of identification of a failure. It was logistics, not strategy, that was winning battles. Klaus obtained documents describing the American tank recovery doctrine. When a Sherman was damaged, either by enemy fire or mechanical failure, recovery vehicles moved immediately to retrieve it. Rather than abandoning it, Americans towed damaged tanks back to repair depots. The critical insight Klaus had was that Americans valued efficiency of logistics above all else. A damaged tank was not a loss. It was a unit that had temporarily left the supply system and would rejoin when repaired. The repair time was measured and optimized. Mechanics worked in 3 shifts to keep vehicles in the shop for minimum time. Standardization meant repairs could be parallelized. One team handling the transmission, another the suspension, another the engine, all working simultaneously rather than sequentially. "Compare that to our procedures," Klaus said, writing notes on a document. "A Panther damaged in combat requires months to return to service because we have no standardized supply chain. Parts must be manufactured, fitted, tested individually. The damage must be understood by hand, by experienced mechanics who've been trained on that specific tank's quirks. We repair tanks one at a time, in sequence, with interruptions when materials are unavailable. They repair tanks on assembly line principles, parallel tasks, standardized procedures, inexhaustible supply of replacement parts. By late winter, the examination had achieved a kind of completeness. The Sherman had been photographed, measured, tested, disassembled, and partially reassembled. Klaus and Friedrich had compiled technical specifications that Friedrich later estimated totaled 200 pages of detailed analysis. The data was organized in a report that Gottlieb forwarded up the chain of command. The report's conclusion was measured but clear. The Sherman was adequate to its purpose, possessed no significant technical deficiencies that would prevent it from performing its designed function, and was supported by a production and logistics system that ensured continuous supply and rapid repair. "We should also include an assessment of implications," Klaus suggested to Gottlieb as they prepared the final draft. "Not just what we've learned about the tank, but what that learning suggests about the broader war." Gottlieb was quiet for a long time. They both knew what Klaus was suggesting. A document that would essentially argue that German military capacity was insufficient to overcome American industrial capacity, that the war had been mathematically lost at a point when neither of them could have influenced it. "That could be interpreted as defeatism," Gottlieb finally said. "It could. Or it could be interpreted as analysis. We were asked to examine a captured American tank and understand it. We've done that. The implications of what we've learned should be included. Write it, Gottlieb said after a moment. Write what you've learned. We'll see what happens. Klaus spent the next week drafting an additional section to the report. He wrote carefully, using technical language to frame arguments that might otherwise be considered seditious. He wrote about production capacity in terms of machinery and labor availability. He wrote about standardization in terms of manufacturing efficiency and training requirements. He wrote about logistics in terms of transportation networks and supply lines. Underneath every technical observation was a single truth. Germany could not produce enough tanks, could not repair them fast enough, could not supply them consistently enough to overcome American capacity. The draft was perhaps 5 pages. Klaus presented it to Gottlieb on a grey morning when snow was beginning to fall again outside the workshop. Gottlieb read it without comment, occasionally making small marks with a pencil. When he finished, he looked up at Klaus. "This is well written," Gottlieb said. "It's logical, it's evidence-based, it's unavoidable. Will you submit it?" "I have to. An analysis that reaches this conclusion based on the evidence would be intellectually dishonest to omit." "But Klaus, understand what you're writing here. You're not writing about tank design. You're writing about the fundamental imbalance in the war. You're saying that no tank design, no tactical innovation, no strategic reorganization can overcome the basic fact that America produces at a rate that Germany cannot match." "That's what the evidence shows," Klaus said quietly. "Yes, it does." The report was submitted through channels, up through Army Command, and eventually to German armor production headquarters. Klaus never learned what happened to his analysis section. He suspected it was read by people who already knew the conclusions, who understood the mathematics of German defeat, and who were powerless to change it. The war ground on for another 3 months, machines continuing to be produced, though the raw materials were becoming impossible to obtain, the industrial base shrinking under bombing, the manpower reserves depleted to feed an endless front. But Klaus and Friedrich had already understood the outcome while standing in that workshop, dissecting a captured Sherman tank. They had read the future in standardized parts, in the evidence of mass production, in the sophisticated simplicity of American design. In the final weeks before the depot was overrun by advancing Soviet forces, Klaus and Friedrich moved the tank components deeper underground, cataloging everything one final time. It seemed pointless. The war was ending. The army was collapsing. The future would belong to people who made decisions that Klaus could not influence. Yet they completed the work with mechanical precision, because it was what they had been trained to do, because order and documentation were the habits they'd developed over months of careful analysis. When the Soviets arrived, Klaus was fortunate to be captured by the Americans instead. He spent 3 years in POW camps, eventually returned to Germany, and resumed work as an engineer in civilian manufacturing. He published no memoir, gave no interviews, kept his experience in the workshop to himself. Years later, after the war was thoroughly historical, a younger engineer who'd worked alongside Klaus in the 1950s at a manufacturing company asked him what he'd done during the war. "I examined machines," Klaus said simply. "I tried to understand what they told me about the world." "Did you learn anything?" the younger man asked. Klaus was quiet for a very long time. "Yes," he finally said. "I learned that mathematics cannot be negotiated with. I learned that industrial capacity is its own form of power. And I learned that in the end, the machine that can be made in greatest numbers by people with minimal training will defeat the machine that requires genius to produce, no matter how superior that genius might be." The younger man didn't fully understand. Klaus could see that. It was a lesson that required experience, required standing in a workshop in winter, looking at a dissected tank that represented the industrial capacity of a nation, understanding that you were on the losing side of a mathematics problem that had been stated years before the first shot was fired. By the 1960s, With the Cold War consuming international attention and memory of World War II beginning to retreat into history, Klaus was invited to speak at a technical conference on tank design and production. American, German, British and French engineers were present, comparing notes on post-war armor development. Klaus was asked to share what he'd learned about American tank manufacturing during his wartime examination of the Sherman. The greatest innovation, Klaus told the assembled room, was not technical. It was organizational. The Americans understood that war is not decided by the most perfect weapon, but by the most available weapons. They engineered for volume. They standardized for speed. They built supply chains that sustained production. Every decision in the Sherman was made with the question in mind: how many can we produce? Not, how perfect can this be? That shift in fundamental approach, that is what won the war. In 1943, an experienced German engineer could have looked at a Sherman and found numerous design choices to criticize. The Sherman is not optimized for any particular characteristic. Its armor is not as well shaped as our armor. Its gun is smaller than ours. Its engine efficiency is lower. But it was designed in an industrial context where none of those critiques mattered. What mattered was that thousands could be produced, that any mechanic could repair them, that casualties could be replaced within days. We lost the war not to superior technology, but to superior organization. The room was quiet when Klaus finished. Engineers from all nations understood what he was describing. The transition from craft to industry, from individual excellence to systematic excellence, from the possibility of genius to the certainty of competence. After the presentation, an American engineer approached Klaus, a man named Robert, who'd worked in tank design for Chrysler during the war years. "I appreciate what you said," Robert told him. "Most engineers are too proud to admit that we won through volume rather than innovation. But you're right. We knew we were going to lose individual tank comparisons. The Panther was a better tank than the Sherman, but there were 6 Shermans for every Panther. When the mathematics are against you, you need a different approach. We chose the approach of making sure the mathematics would be against our enemies." Klaus nodded slowly. "In my final report during the war, I wrote that America could produce more tanks than Germany could destroy. That seemed obvious to me at the time, but it was not obvious to my superiors. They wanted to believe that superior design could overcome superior capacity. It couldn't," Robert said simply. "Not at the scale we were talking about. The war was decided not in design bureaus, but in factories, not in battle, but in production cycles. That's uncomfortable to admit for engineers who take pride in design, but it's the truth." In the decades after the war, as Klaus grew old and watched the world transform, he sometimes thought about that Sherman tank sitting in the workshop in winter, its systems laid bare, its secrets accessible to analysis. He thought about the moment when he'd understood that the war was fundamentally lost, that no amount of engineering brilliance could overcome the basic asymmetry of industrial capacity. It was a lesson in limits, in the way that rational systems could triumph over brilliant individuals, in the way that mathematics ultimately determined outcomes that humans thought would be decided by will or skill or courage. When Klaus died in 1987, historians would later interview his widow and compile fragments of his wartime testimony. The examination of the Sherman became a footnote in various histories of tank warfare. The broader lesson, that industrial capacity and standardization defeated complexity and craft, was something that military theorists and engineers continued to argue about, sometimes acknowledging it, sometimes resisting it. But Klaus had learned it standing in that workshop, and it had shaped his understanding for the rest of his life. The machine that could be made in greatest numbers would win. That was the lesson of the Sherman tank, the lesson that history kept teaching and that humans kept having difficulty believing until they'd lived through the proof.